Alright, this video is meant to be a help for you as far as understanding what a combination is. In order to understand a combination, we first need to understand how it relates back to a permutation. Permutations are when order matters. Combinations are when order will not matter. So when we look at our formula, permutations will be n factorial, or NPR, if you're taking n objects permuted r numbers at a time. We're going to take n factorial divided by n minus r factorial. Such as, when Alex claims he can predict the finishing order of the top 3 horses, how many different ways, how many different orders, essentially, can he finish those? Well, permutation will be 7p3, as in there are 7 horses, but we're going to pick 3 at a time. I only care about the top 3 finishers. So 7 factorial over 7 minus 3 would make 4 factorial on the bottom. And 7 factorial is 7, 6, 5, 4, 3, 2, 1. But remember that 4 factorial already has the 4, 3, 2, 1 on the bottom. So we can sort of cancel those away, right? Get rid of all that stuff. And basically 7 times 6 times 5 will end up giving us 210 possible finishes. Well, if Julia doesn't care about the order, she just wants to predict the top 3 horses, then if horses A, B, and C would have finished for Alex, that would be different from horses B, C, and A. Well, Julia, it's the same 3 horses. ABC is ABC, BCA, CBA, it doesn't really matter. So we're going to cut that way down. Anytime it was the same 3 horses, just in a different order, that's the same combination of horses. And you'll notice that the combination formula is very similar to permutation. It's the n factorial, again, divided by n minus r factorial. I'm still going to drop those bottom 4 horses. But in addition to taking 7 factorial over 4 factorial, we're going to divide by 3 factorial every time that the same 3 horses would finish in a different way. That's not a difference for us. We just want the grouping. So again, 765 times 4 factorial. We've also got that 4 factorial on the bottom. So again, that part's going to disappear as it did the first time. But also, we've got this 3, 2, 1 taking away those orders, which will cancel with the 6, and essentially in the end we'll end up with 35 total ways, total combinations, if you will. Again, a combination is just counting the number of ways n distinct objects can be chosen r at a time. I'm not worried about the order, however. So, a great game to demonstrate that would be the game of poker, a standard poker deck of cards. So 52 cards, again, 4 different suits. You've got your clubs, your hearts, your diamonds, and your spades. Again, hearts and diamonds being red, clubs and spades being black. And we've got 13 cards, ace through king, in each one of those suits. When you're dealt a 5-card hand in poker, however, it doesn't matter the order you get the cards. You can pick up all 5 cards, you can move them around all you want. It's the same hand of cards. It's the same group of 5 cards. So how many different poker hands are possible? Well, this is a definite time to work with combinations. So let's go ahead and write down. We've got 52 cards to choose from, and we are going to choose or find the combinations of 5 cards at a time, which basically gives us 52 factorial on the top, and then we can say 5 factorial, or r factorial, right, the number of cards we're choosing from at a time, times 52 minus 5, or 47 factorial on the bottom. You could either type that 52 choose 5 into your calculator, or the 52 factorial divided by, now make sure you put a set of parentheses around the bottom here, if that's the case, but 5 factorial times 47 factorial. Either way, you should end up with 2,598,960 possible ways. Again, a lot of different poker hands that you can get. Again, that's what makes the game fun. So again, that's a combination. Again, to demonstrate doing that on the calculator, let's just bring up our calculator. And again, if you have a TI-84 Plus or a TI-83, basically the idea is you're going to go to Math. That's that button over there at the left, right underneath Alpha. We're going to go over to the probability menu. Again, these things are going to help us with probability later on in our studies. Then we're going to choose combinations. Same place we would have gotten permutations and number 2 there. Number 3 is now combinations, and notice number 4 was factorial. So we're going to choose number 3. Now I forgot to put my first number in, so I want to type that number in first. I want to make sure I get it 52. Choose 5. Right? I want to type in that same thing. So I'm going to say 52. Now I've got to make sure I insert that 2 there. And I'm going to choose 5. And again, very simply, press enter. And there, like I said, is that 2,598,960. Again, pretty simple to type that into the calculator. Now, the next thing that's going to help us out is, hey, if we can find combinations, now how can the kind of our problems sort of muck us up a little bit, right? In how many ways can 5 card hands all be the same color? How can all 5 cards be the same color within that hand? How many different possible hands is that? Well, instead of choosing out of the 52 cards, basically we want to choose from our 26 then. There are 26 red cards that we can choose to use. I can get the pen to actually write 26 here. There we go. And we're choosing 5 cards at a time. But wait a minute, there are also 26 black cards. And we're going to choose 5 at a time. So what we've got to realize is this is an OR equation, or an OR question. 26 choose 5 will get us all the possible red card hands. That's all the possible ways we can take the red cards and mix them around in various groupings, again, combinations. Or we could do 26 choose 5 to get the black cards. Again, that word OR, the key is it typically means and. So what we're going to do is we're going to add those two numbers together once we've got them. And if you do that, again, type it very carefully into your calculator, you should end up with 131,560. Again, just a few of the hands within that 2 million, 2.6 million almost, hands possible. How many 5 card hands contain 3 or more face cards? Well, again, we've got that word OR in there. So what we're going to need to do is set up for 3 cards. So again, I'm going to do a combination. I'm going to do 3 cards at a time. I'm also going to have to do a combination for 4 cards at a time. And I'm also going to have to do a combination of 5 cards at a time. Okay. Now, where am I choosing those cards from? Again, they need to be face cards. There are 12 face cards in the deck, Jack, Queen, King of each of the 4 suits. So out of the 12 cards, I'm going to choose 3 cards. Again, out of the 12, I'm going to choose my 4. And out of the 12, I'm going to choose my 5. Now, I can have either those 3 cards, those 4 cards, or those 5. Again, if I get an extra face card, that's a different scenario. So again, I've got to kind of add those together. And then the other thing we want to realize is, again, to make a full hand of cards, it actually takes us back to the fundamental counting theorem. If I'm going to have 3 face cards, it also implies that I have to also have, or 3 face cards, and I need to have 2 other cards to fill my hand. So I'm also going to make a combination of, well, I need 2 more cards to fill my hand. Well, those 2 cards have to come from the 40 non-face cards. Okay. Because again, 3 face cards and another face card would put me in a different scenario. So I need those 2 cards to be non-face cards. Well, there's 40 non-face cards in the deck. So let's do the same thing for the 4 card hand. Again, I need 5 total cards to make a hand. So we're going to take out of those 40. We're going to choose 1 more card. Now, I don't necessarily need to put anything with my 5 cards because, again, if I've already got 5 face cards, that's a full hand. So we can just stop there, calculate those numbers out. Again, multiply for 3 cards and 2 cards, 4 cards and 1 card. But then I need to add. I need to do that OR for 3 face cards or 4 or 5. And you should end up with about 192,192 possible hands with those cards in them. Yeah, I hope that helps you understand combinations a little bit. I also hope that helps you understand the difference between and OR. And again, 2 things are going to happen at the same time. For one thing to happen and another, we're going to multiply. For one scenario to happen or another, again, we're going to add. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day and happy counting.